Let's determine the y of s of this initial value problem by applying the Laplace transform. So first, I'm going to apply Laplace transform on both sides. So therefore, this will become Laplace transform of y double prime plus y prime minus 2y, and this equals Laplace transform of 2e power minus 3t. Now, applying the linearity property of Laplace transform, we can write this as Laplace transform of y double prime plus Laplace transform of y prime minus Laplace transform of 2y. And this equals, we can factor the 2. So therefore, this becomes 2 times of Laplace transform of e raised to the power of negative 3t. Now, I'm going to use these two formula. That is, Laplace transform of y double prime is given as s squared Laplace transform of y minus s times of y of 0 minus y prime of 0. So let me use that formula. So therefore, this becomes s squared Laplace transform of y minus s times of y of 0 minus y prime of 0. So this I have used the formula for Laplace transform of y double prime. Now let me use the Laplace transform formula for y prime. That is s times of Laplace transform of y. That is we are using this formula. So it becomes s times of Laplace transform of y minus y of 0. Then we find the Laplace transform of 2y. So I can factor the 2 and then take the Laplace transform of y. And this equals, we will have 2 times of Laplace transform of e raised to the power of negative 3t. Now we'll apply the initial values, that is y of 0 equals 1 and y prime of 0 equals negative 2. So this is y of 0 is replaced as negative 1, and we will replace this as negative 1. I'm sorry, it is positive 1. So this is 1 and these two are 1 and this is also 1. And then we have to replace y prime of 0 as negative 2. So therefore, this will be replaced as negative 2. We have only one y prime of 0. So let's simplify. So this implies we have the first term as s squared Laplace transform of y. And then s times of 1 is negative s. Then negative of negative 2 is positive 2. Plus we have this term s times of Laplace transform of y, and then this is replaced as 1, so it becomes negative 1 minus 2 times of Laplace transform of y, and this equals 2 times of Laplace transform of e raised to the power of negative 3t. Now we will factor the Laplace transform of y's and also simplify the other terms. So we have a Laplace transform of y over here as well as here as well as here. So when we factor this Laplace transform of y, we'll be left with here we have s squared and here we have plus s and here we have negative 2. And then we will simplify the other terms. So the other terms are negative s and positive 2 and negative 1. And on the right side we have 2 times of Laplace transform of e raised to the power of negative 3t. Now we can simplify this. So this equals a negative s plus 1. So I can put this as negative s plus 1. So therefore, we will write Laplace transform of y times of s squared plus s minus 2, and then negative s plus 1, and this equals 2 times of Laplace transform of e raised to the power of negative 3t. And we will also apply the Laplace transform for this one, that is for e raised to the power of negative 3t. And for that, we can utilize this formula. That is, Laplace transform of e raised to the power of at is 1 over s minus a. So when we use this formula, the Laplace transform of e raised to the power of negative 3t is 1 over s minus of a is negative 3 here. So it becomes s minus of minus 3. And so therefore this becomes 1 over s plus 3. So I'm going to replace this as 1 over s plus 3. We do that. So we will replace this as 1 over s plus 3. Remember, we have 2 in front. So it becomes 2 times of 1 over s plus 3. And then we will also subtract this on both sides. So that means we have to add positive s and negative 1. So positive s and negative 1. So these two gets cancelled. And we have this terms. So let's rewrite this. So we have Laplace transform of y times of s squared plus s minus 2, and this equals 2 over s plus 3 plus s minus 1. We will simplify this right side expression. So I'm going to multiply this factor, the second factor, by s plus 3 s plus divide by s plus 3, so that we will have common denominator. So therefore this becomes 2 times of s minus 1 times of s plus 3 over s plus 3 is the common denominator. We'll FOIL this out. So when we do that, we get 2 plus s times s is s squared, and s times 3 is 3s. Negative 1 times s is negative s. Negative 1 times 3 is negative 3. This is all over s plus 3. We can combine the like terms. So 3s minus s is 2s, and 2 minus 3 is minus 1. So finally, we have this expression, that is s squared plus 2s minus 1 over s plus 3. And on the left side, we have the expression, that is Laplace transform of y times of s squared plus s minus 2. In fact, we can write this as a product of linear terms by factoring. So I'm going to do that. So therefore, Laplace transform of y times of, when we factor this, we will get s plus 2 times of s minus 1. And this equals s squared plus 2s minus 1 over s plus 3. We will now divide both sides by this expression, that is s plus 2 times of s minus 1, so that we will have only Laplace transform of y on the left side. So we will have Laplace transform of y, and this equals, when we divide by that term, we will have s squared plus 2s minus 1 in the numerator, and we have s plus 3, and when we divide, these two factors will also get multiplied. So it becomes s plus 2 times of s minus 1. Now Laplace transform of y, this is written as a function of, that is y of s. So this equals s squared plus 2s minus 1 all over. I can put this as the first term, so s minus 1, and then times of s plus 2, and finally the last term is s plus 3. So we have determined the y of s for the initial value problem. So this is the expression for y of s. Therefore, answer choice 4 is correct.